Hello students, this is lesson number. So I'm gonna walk through you lesson number 8. The last time we did 7, 6, and 7. This lesson is about understanding the period of a function. Now see, I can understand the graph of periodic function and can look like a wave whose outputs repeat between the same maximum and minimum. So let's see what's going on here straight away with the. So the first one is, if you see here, what do you see and what do you wonder? So you're supposed to write here. I want you to pause the video for some time and see what you see here. Okay. So there's some distance from star lines. I mean start line. This is miles. So what do you think is what you see is here is the graph. So let me say the graph that you see here is the graph goes up. So you can see that you can write down the graph goes up and then the graph goes down. See? And the same thing is again repeats that part E is repeated, goes up and then goes down. And then again the same thing repeats, goes up and then goes down. So the maximum distance, so if you see how high it goes, if you see here, if I want to see how much is this is given to the distance in the start line, and maybe this is a could be a question about a car. So this if this is a car, a racing car. So if this is a racing car, and then it's starting line, and this is like a, and this is the where it starts, and then it goes up. So that's how the distance from the start. So it could be like distance from the start, and then within 1 maybe this is I don't know. This is 1.6 minutes maybe. So it goes all the way up maximum. So that's maximum maybe is like 1.4 miles. So that's like miles. It goes 4 per mile. And then it goes down. So then it goes down like this. When I mean it approaches back to that. That means this is the height goes on decreasing. See, this is the height. So that means this is a zero height. So each cycle takes about less than 2 minutes. It means it goes up. So look at this, it goes up and down. So it's like less than, so the one side, this is like a one cycle goes up. It means it goes around and comes back. That's one cycle. Then again it goes around and come back. Again it goes around and come back. So that those are the graph. It goes up, down, and it repeats every 1.6. So it's like that. This is called period of the function, whatever the function. This will have some function. And you will see this is also called sine function later classes. And if I try to drop a midline here, and you can always create a kind of a point where it just goes up, down, up, down, up, down. So which is called a sine function, and it repeats after every 1.6. So right now, what is important? What do you see? Now, what event does the graph represent? So I already said it could be a car racing starting point, and in the every time it goes, there will be some distance. If this point, there's some distance from the ground, this part. If it is here, there is a some distance. If it is here, and that's how it is maximum. See? And then again, the distance goes down. So the distance goes down, and then again back to zero. So hope that helps. And what the meaning of when the distance is zero, it means you are back to the same. If this is the starting point, it goes, then come again back to the starting point. See, that's where the distance of the car from the start line is zero. So hope that helps. Let's go to the next one. So in this case, you'll be given three options. This is 8.2, and what option they give is there are some relations that produce graph that have repeated nature, which is the period. For each, describe what is independent and what is dependent and independent variable. How does the dependent variable change, and what might cause this change? Now, this is the first one. So this is the graph of the distance of the race car from the start line as it goes around the track. So I already showed you. It's like a track. Okay, so maybe this way. This is the track. Okay, and maybe this is the point, this is the starting point, this is the starting point, and it goes around the track. This is the track with the car racing, and this is the starting point. So there it is, and already done to you. So the question is, which is the dependent? So this time means, so this is minutes time passes from the starting point. So you're supposed to write in your own English words that what is the independent variable. So this becomes your independent variable at time because the distance of, let's say the car is right here. If this is the car, this height, so after certain time it always will have some height here. So this height, the distance from the start line is called, this is dependent. So how far away is the car, this car, from here? So that's the So this is asking you that it means if this is the point, that the mistake I did in my first 8.1, this is 8.2. So what it means is every time the car, let's see, this is the distance. If the car is here, that's the distance. So if this is the thing, that's the distance. So this is what it shows you, not what I showed you from the ground. No, that's not what it is. It is from the start point. That's how it is. So anyway, but the idea is the same. This is the independent variable. The time is the independent variable, and the distance, how far away the car is. This distance d is depend on the time as time progresses. So hope that helps. And let's go to the next one. You can see like that this is the graph of the temperature in a city over 21 days. So from the from the from 22, so if you see this one, so all you see is that within this 21 days, these are the days passed. So this is the dependent variable. Remember, this is the days. D is the dependent variables, and depending on the days, see the temperature in a day, the temperature at this point goes up and then goes down. So goes, and then the same thing. Now this part repeats again. See, from here, it's the blue color I'm drawing. This goes, and here. And then again, let me use, so basically there's a repetition every day. It goes up and then goes down. So all you're supposed to write, there's a period here. Like every day there's one cycle. See, this is one cycle. This is another cycle, another cycle, another. Every day that goes up, and that's the maximum. So you can see there's the maximum temperature, and this is the minimum. So anyway, every day, look at this. There is a minimum, maximum, minimum, maximum, minimum, maximum, minimum. So from maximum to maximum is like a one period. The period is also called cycle. So all you're supposed to write in this case is this is the independent, uh, and this temperature is dependent variable. So as the days pass by, the temperature goes on changing. So in each day, it goes up and down. That's all you're supposed to remember. Let's go to the next one is, if you see this is animal hair and links that's been given from 1845 and so on. And you can see thousands of animals. The red one is the hair, and the blue one that you see here is the link. So what you're supposed to do is, what is the dependent variable here? Independent is how many years passed since. So years. So here you're supposed to years since 1845. So 1845 is the start. So from here, how many years passed? And you can see, let me show the hair. If you see this hair, and independent is how many thousand number of animals are there. So this is in the forest, maybe how many thousands of animals, or maybe in a whole global scenario. So since this is the red color, what the red color is starts here, 1985 goes up, okay, and you can see, and then goes. So there is a so it looks like it starts, it goes up here, and then it starts here, then goes up and goes down. Again, it goes up and it goes down. Again, it goes up and goes down. So it's almost like a 10 years, it goes up and then down. 10 up, up. So every 10 years there's a period of that minimum and maximum. So that's the so two things. One is that's the independent variable, and number of thousands of animals is the dependent variable, and the cycle is repeats every 10 years. That's all. But for the other one, I think even for if you see for the links, that also I can use a blue color. So this is a blue color. See, goes up, down, up, down, up, down. So 5 years. So this is like 10 years, 10 years, 10 years, 10 years, 10 years, 10 years, 10 years. So every 10. So the cycle is the period is 10 years for both the population, the hair and the links from the start of 85. So hope this makes little understanding what is independent variable and dependent variable and the repetition. Let's move to the next one is what you're supposed to do here is a teacher will give you means I'm not getting a printout, but actually you were supposed to give one cards, but I'm gonna do that directly. I have a lot of graphs here. What you're supposed to do, watch those graphs and check which one is linear, exponential, quadratic, and periodic. You also have to see whether it is continuous and what is the meaning of discrete. And you also have to see is there a positive vertical intercept, negative or zero. Also, you can sort with positive values, only negative values, both positive and negative values also that cross the x-axis. So I'll go straight away to the problem. This one, look at this. The first problem when you see, what do you see is the A. The first one here is you can see there is a dots, they are in a line but they are discrete because if they are not connected, if they are connected, now look at this doesn't have a dot, it's just continuous. That's the exponential. So this is so the main thing what I want you to write, this is I want to make a sketch on the paper and say, hey, that's exponential function. This is also function, but this is discrete. Okay, discrete. This one has both vertical intercept, horizontal intercept. This one only has the vertical intercept and above the x-axis, which you guys know. So the understanding of what is discrete and what is continuous. This is continuous. This graph is continuous because there is no break, but this one there is a break. See, in between there's a break. If you see the next one, This is a this is a parabola, right? This is a parabola, if you remember, which is concave up. It opens up and it's a quadratic with a degree 2, opens up, and it also has both vertical. This is the vertical. The vertical and the horizontal intercepts are the same, for this, but there's also here another horizontal intercept. So main thing is continuous. So this is continuous, okay, and it has a zero. One of the intercept is the same. So this is not periodic, but if you see this is periodic. So you see this graph, it repeats like this graph. This repeats graph. So it's kind of a repetition of the graph. This is it is not continuous because there's a break. So you go like this, and there's a break here. So there's a break here. There is a break here. So this is not continuous. So this is not continuous. This is not discrete also, but it is periodic. So this is the important main key. This is periodic. It repeats. This is repeat. The green thing repeats. This is repetition, and the way it shows it repeats. If I check this out, and if you see somewhere here, it's like pi by 2. So this is this. If this is pi, this is pi by 2 and this is minus pi by 2. And later on you'll see this is the graph of 10x where the graph goes like this. It's like this. So that's the graph of 10x and it is goes down up. We see the next one. This is the line, so you can clearly see this is the line, this is the line, continuous. This represents a linear function. And this one is a line, continuous. So this is continuous. So not periodic. So it does not periodic, and it is also not discrete. So if you see, and the next one is dot dot. Whenever you have dot dot, means this is discrete. Okay, and it takes the shape of like a. It is like an exponent. It's like a. There's an exponential decay here. Exponential decay, or they actually represents kind of a. If you see this dot, they represent sequence of points, which is this is discrete. That's all you can write. This is discrete, and it is also a function, a decreasing function. This will be decreasing, or you can say this is a decay exponential. There's an exponential decay. Yeah, and then let's see the next one. You will see here there's a parabola. This is a quadratic, parabola, continuous. All these words you're supposed to write here. Parabola, open the correct part. This we did, and it is not periodic. It's not discrete. If you see the next one, if I start like this, this is see this part, and then again the same thing repeats. See, so these are called periodic. Okay, so this is not linear, not a parabola, not quadratic, exponential, but this is also sinusoidal. This is sinusoidal, and it's going to be either we can think of like a cosine function or the sine function. We'll see later on. And the last one almost there. This I showed you. This is a linear, continuous, but the other one is exponential. This is exponential, continuous. And there is a positive. The range is positive here. Here, if you see here you will see the vertical intercept and the horizontal intercept is the same, but for this one there is a horizontal vertical intercept. If I make this a little bigger, something like this. So there is that vertical intercept. It does not have a horizontal, and there is this is exponential growth or exponential growth function. Okay. If you see this next one is you can see this is discrete. Can you very clearly you can see discrete, and there is a repetition. The graphs. If you see, oh no, this is discrete, but it is like parabolic. Can you see this is like a parabolic? This is a parabolic, and it is defined only for a few values of the domain is not everything, but like maybe it goes up like this, but domain for only certain axes. That's discrete, and it's not periodic. If you see this one, this goes up and then goes down. That's one, and then this is periodic. So this is periodic, repeats, and that's all that means. You will see from here to here is like you see this is 2 pi. So there is a 2 pi. That means the graph repeats, the cycle repeats every 2 pi. And what will you see then later on is this is like a minus cosine of function that we'll see later on. Watch this problem. Oh, again, linear, there's a vertical intercept, horizontal intercept, continuous and linear and all that. But so this is not discrete, it is not periodic, but there is a, this is an exponential function like this, but this exponential function, which is something like this, maybe, okay, so it's a reflection of the exponential function. It's a continuous function, does not repeat, and it has been moved. Maybe there was a function this way. This function first it reflects it goes this way, and then it moves to the right side and it goes this side and then reflects over the x-axis. So something, but main thing you just write is, oh, that's just the exponential function, and you can see it's a continuous. The last part, and I'm done. Oh, this is the reflection of a parabola. This is the original parabola, reflects, continuous, and everything. The range is negative. So this is not periodic. This is continuous. That's all you're supposed to write. This is a discrete. This is a repetition, but discrete. Look at this. This goes like this and goes up. So, and the same thing repeats again, goes down and then goes up. So this cycles repeats after every 2 pi. So this 2 pi And that's the graph I was talking about. It's you will see later on. This is cosine function. Okay, so that's it I wanted to say. Hope you understand at least something. And do write all that everything that I spoke. This is discrete. The main thing I'm supposed to write this is here. This is this because in between there's a gap. See, it's not connected. And then there is also what is it called? Period. There's a cycle. So the period and the period is 2 pi here. Okay, thank you. And I will soon try to make another one. We'll go over the lesson 7. If I go here, what is the, let me check here, cool down. And oh, cool down is also given, see. This one shows you, here's a graph of high tide, of the tide height of a tide. Delaware, full day this shows you like 24 hours, so starting from midnight. Maybe this is like a 0 starts, and that's the height of the tide is like, so that's like a 4 point, I don't know, this is 5, maybe 4.2. So the height maximum was height, and the minimum you will see it is not. There's something little piece, maybe that is like if this is 2 and this is 1, maybe this is 0.2, very little height there in feet. So that means you can see what are the question. How does the dependent variable change? So dependent variable is the height of the tide. So that means it depends on how many minutes, how many hours have passed from midnight. And this is dependent. Sorry, this time that passes from the midnight is called is the independent variable. Okay, but the height of the tide, so this is how it goes up, down, up, and you can see the period it repeats. You can see, let me take this off and say, hey, what's the period here? And you will see, let's imagine this is the we can start from here 0, and you can see exactly at 12 noon. This is 12 noon, and this is 12 morning. So in 12 hours, the period repeats. So the height maximum then become maybe 0.2, and then again maximum. That's the period. And I hope I understand what's happening here is like this. So hope that helps. Just wanted to show you. Later on you'll see there's a midline here, somewhere here like this. And you will see we can create a function of this one like this, a cosine kind of a thing, where there's almost like a 1, maybe 0.9 here, and you can see that this will be called amplitude. So you will see later on this will be called amplitude, and this is also called, this is the period is 12 hours. Okay, 12 hours, and then you can write down. So and this is the one. If you see this hard, this is also called, it was here in the beginning, it is here, but now it goes up halfway between the minimum and the maximum is the midline. Maybe it is 2.1, I don't know. Maybe it is 2.1. So you try to create a height function depend on t, and you are using the midline as 2 here. So you put like 2.1 maybe, and then you have the amplitude is about 0.9. So 0.9, and you put cosine, and you put something variable t, and you can say it is 2 pi. So you will see you'll write 2 pi because the actual cosine function period is 2 pi. So you have to divide it by the whatever this one is, which is 12. So we get 6, pi by 6. So this one will be pi by 6, pi by 6 times t. So even though you don't understand this, that's okay. We will see this in the next later classes. Thank you for watching, and hope this makes sense.